Hello, hi. We're going to be working with natural logarithms this lesson. As you can see, the graph of y equals ln x is a reflection of the graph y equals e to the power of x. And that's reflected in the line y equals x. Your y equals x, and that's y equals ln x. You should recall from previously that log to base e of x is equal to ln x. So click pause, make a quick sketch, and we'll look at a couple of examples there. So we've got our example. We're going to try and solve A and B. Case of A, first thing to do is take logs both sides. So taking natural logs both sides. So we have log to the base e of e to the power of x is equal to log to the base e of 5. Now we can use the power law, and that's going to say we can simplify that to give us x log to the base e of e is equal to log to the base e of 5. Power law. And we know that if you got the base and a number the same, then log to the base e of e is 1, which means we've got x is equal to log to the base e of 5. Looking at the second question, we've got ln x is equal to 3. Now we know that ln x is log to the base e, so we can write log to the base e of x is equal to 3. And we can simplify that. E to the power of 3 is equal to x. Now we're going to solve the equation e to the power of 2x plus 3 is equal to 7. I should write it down here. E to the power of 2x plus 3 is equal to 7. I want to take natural logs both sides. That means I've got log to the base e of e to the power of 2x plus 3 right, 2x and 3 is equal to log to the base e of 7. Remember, log to the base e, I could write that as ln e. I'm writing this in this form because now I'm going to use the power law and simplify that to 2x plus 3 log to the base e of e is equal to log base e of 7. Now log to the base e of e is 1, so that means 2x add 3 is equal to log to the base e of 7. I could write 2x add 3 is equal to ln 7. And solve for x, 2x is equal to ln 7 minus 3, and x is going to be equal to half of ln 7 minus 3. Okay, next example, solve 2 ln x plus 1 equals 5. So we have 2 ln x. So the simplest thing first, you take that plus 1 over the other side, you have 2 ln x is equal to 5 minus 1, which is 4. I can divide by 2, divide all the way through by 2. That gives us ln x is equal to 4 over 2, which is 2. Now ln x is log to the base e of x, which is equal to 2. So that means that e to the power of 2 is equal to x. Solved. Or you could write x equals e to the power of 2. Final example with this one. Solve e to the power of 2x plus 5 e to the power of x equals 14. So we write it here. E to the power of 2x plus 5 e to the power of x equals 14. This is a certain type of equation. Let's bring the 14 over to the left hand side first, and then we'll see if we can identify that. So there's e to the power of 2x plus 5 e to the power of x minus 14 is equal to 0. Hopefully you would identify that as a quadratic equation. So you could say let y equals e to the power of x. So if we just do a little equation here, then that would mean that we'd have y squared plus 5y minus 14 equals 0. And then we could solve that in terms of y. So you'd have y, and then we need factors of 14. That's going to give us give us plus 5. So plus 7 minus 2. So either y is equal to minus 7 or y is equal to 2. Can't be negative. So that means you've got e to the power of x is equal to 2. And that's going to give us then log to the base e of 2 is equal to x. Or we could just keep it as e to the power of 2x and then solve the equation here. So we've got e to the power of x, and e to the power of x will give us our e to the power of 2x equals 0, and we're looking for the factors of 14 again. So plus 7 minus 2. So that implies then either e to the power of x is equal to minus 7 or e to the power of x is equal to 2. It's only positive solutions. Therefore, e to the power of x is equal to 2. As we did before, that means that log to the base e of 2 is equal to x, or x is equal to ln 2. And now you've got some exercises to tackle. Good luck, enjoy. Don't forget solutions are in the files section of Teams.